Good morning, children. This is Aisha again. So I'm here with the last but very interesting subtopic from the lesson Matter in Our Surroundings, which is evaporation. In my previous videos, I taught you about the effects of change of temperature and pressure on the interconversion of states of matter. And today we will learn about evaporation, the phenomenon called evaporation. So before we go straight into the topic, let us just recall one characteristic property of matter. We learnt that the particles of matter are continuously moving. If you take an example of a liquid, even in liquid, the particles are free to move and they are continuously moving. That is, they are associated with some amount of kinetic energy. But some particles in a liquid always have more kinetic energy than the others. So we have learnt in our previous video that at the boiling point, the particles gain a lot of kinetic energy by absorbing the heat, and then they overcome the force of attraction and they change into vapor. And this is all happening at the boiling point. But some particles in a liquids always have more kinetic energy than the others. So even when, please listen very carefully, even when the liquid is well below its boiling point, some of its particles have enough energy to break the forces of attraction between the particles and escape from the surface. So this surface phenomenon is called as evaporation. Hope you understood the difference between vaporization and evaporation. So vaporization is nothing but changing of liquid into vapors at its boiling point. But evaporation is a process where even when the liquid is much below its boiling point, some of its particles are changing into vapor or into gaseous state by breaking the forces of attraction between the particles. So this phenomenon is called as evaporation. So here's the definition. The process of liquids changing into vapors even below its boiling point, this is more important, is called as evaporation. You can see a diagram over here. You can see a diagram showing evaporation. You take a tripod stand and there's a source of heat here. So you put a dish, it can be called as an evaporation basin, in which the solution or the solvent is taken or any liquid is taken, and then when you provide heat energy, slowly what happens? So please understand one thing, that we are not increasing the temperature up to its boiling point. We are simply warming it. So what happens? Slowly you can see the solvent vapors. So this is called as evaporation. Let us now understand what are the various factors that affect evaporation. Let us talk about the temperature first. So the rate of evaporation, as you know, that it increases on increasing the temperature. As you know that when you increase the temperature, the kinetic energy of the particles also increase. And as you know now that when the kinetic energy of a particle is increased, it can break away the forces of attraction and can become into vapors. So when you increase the temperature, the evaporation also increases. So can you give an example for this? So the washed clothes, the wet clothes dry easily during a hot sunny day. When you compare it with a cold day, the washed clothes, they dry up quickly during a hot sunny day because the temperature is higher when compared to a cold winter day. The second factor that affects evaporation is surface area. I'll give you one small example here. Take same amount of liquid in a test tube and a china dish. You know what's a china dish? A watch glass, like a shallow vessel. So you can take a test tube and a china dish and you add same amount of water in both of them. Now observe carefully. So in which of these two do you think the water will evaporate more quickly? Yes, obviously, when the water is spread on a shallow china dish or on a shallow surface, where the surface area is more, you can see the surface area is maximum, or what you call it's more when compared to the surface area of the test tube. So here you can understand that the more the surface area, the faster is the evaporation. The third point is humidity. What do you mean by humidity, children? It's the percentage or the amount of water vapor present in the atmosphere. So, when the amount of water vapor present in the air is less, it's called as dry air. What is it? When the amount of water vapor present in the air is less, it's called as dry air. So, during such conditions, the rate of evaporation will be higher. When the humidity is high, the evaporation rate is low, because when the humidity is high, it can no more hold that extra vapor. So evaporation will be slower. So can you give an example for this humidity? So the washed clothes, wet clothes dry more quickly on a sunny day when compared to a damp rainy day. That's because the damp season, rainy season, contains a lot of moisture already present in the atmosphere. So it does not allow, it cannot hold any more of moisture to be taken up into the atmosphere. So the evaporation rate becomes slower. The next point is wind speed. So when the wind speed increases, the particles of the vapors move away with the wind. So this increases the rate of, again, evaporation. So again I can give the same example. The wet clothes dry quickly on a windy day when compared to a non-windy day. So if you understood the various factors affecting the evaporation, the rate of evaporation increases with the increase in temperature, and the rate of evaporation again increases with the increase in the surface area. The rate of evaporation decreases with the increase in humidity. The rate of evaporation decreases with the increase in humidity, and the rate of evaporation increases with the increase in the wind speed. So now we are heading towards another concept of evaporation, that is evaporation causes cooling, the cooling effect of evaporation. So it is based on the fact that when liquid evaporates, it draws the amount of heat equal to latent heat of vaporization. We have learned this in our previous videos, no children, that in order to change the state from liquid to vapor, the liquid should get the amount of heat equal to the latent heat of vaporization from its surroundings. So this causes cooling. When the heat is taken away from some body, that body becomes cool, isn't it? So this evaporation, it causes cooling, as the liquid that is going to be evaporated takes away heat from the surroundings and makes the surroundings cool. One very good example that I can give for this effect of cooling that is caused by evaporation is sweating. So sweating is in fact a very good mechanism of the body to lower down the body temperature. So commonly we sweat a lot on a hot day or during summers, isn't it? So what happens once we sweat? So once the sweat is out of our body through the pores of the skin, the sweat, in order to evaporate, it takes away the body heat, and that amount of heat should be equal to the latent heat of vaporization. And then some of the particles of the sweat, they take in this heat energy from the body and they change into vapors. So this evaporation of sweat is happening only by absorbing the amount of heat from the body. So the body is losing certain amount of heat in the form of vapor, sweat vapor. So this is how the body cools down once we sweat. Can you find out similar examples where you can say that evaporation causes cooling, children? Let me see